Alright, here's your first set of notes that you'll be doing on your own at home. Your title is Points, Lines, and Planes. There's our title. Our date is September 9th, 2013. You need a composition book, pencil, and the worksheet I gave you in class. Okay? Alright, your do now was supposed to be which one solved it wrong, but it didn't transfer what I had written underneath. So instead, I want you to solve the equation 2x plus 60 minus 4x equals 100. Solve that, and then tomorrow in class we'll look at what the Panther did, what the Bronco did, which one was right and which one was wrong. Okay, so our learning goal is today we will learn about undefined terms and use those terms to define basic geometry terms. So you're going to use this learning goal to write your essential question on your notes. We've had practice, give it a try, and we'll talk about it tomorrow in class. Why are we learning this? This does not need to be written down. This is just for your information. Alright, so I gave you a table in class today. Tape or glue that to your spiral right underneath your essential question and do now. And we will fill it in together. So a point is named by a letter, and this is the representation. So in point, named by a letter would be written here, and the dot with an A would go in that box. Named by a lowercase cursive letter, or by 2 points on the line, goes here. Your two pictures go here. Named by a capital cursive letter, or by 3 non-collinear points in the plane, goes there. This picture goes here. Alright, so underneath your chart, I want you to name 2 more real-world situations that depict a point. The tip of a pencil lead is one that I would use. You cannot use that one. Name 2 more real-world situations that depict a line. The edge of a piece of paper would be one if it extended forever in both directions. It's really hard for us to think about things that extend forever in both directions in our world because they don't. But if we could extend that edge of a piece of paper forever in both directions, that would be a line. Same thing with a plane. Planes extend forever in all directions. So a desktop would be one if we could extend our desktop forever in 4 directions. Okay? Come up with 2 more of each on your own and write a book. Now here's some vocabulary terms you need to write in your notebook. The space is a set of all points, boundless and 3-dimensional. Collinear is a set of points that all lie on the same line. And notice your hint here. This is very important. 2 points are always collinear. 3 points must be checked to determine if they are collinear. Non-collinear is a set of points that do not all lie on the same line. Coplanar is a set of points or lines that all lie in the same plane. And again, we have a hint, very important. 3 points are always coplanar. 4 points must be checked. Non-coplanar is a set of points or lines that do not lie in the same plane. 2 non-coplanar lines that do not intersect are what we call skew lines. And 2 coplanar lines that do not intersect are parallel lines. Now we need to write these words and draw the picture. 2 lines intersect at a point. Here's 2 lines, here's their intersection, and that is a point. 2 planes intersect at a line. Here's 2 planes, they intersect right here, that is a line. And a line and a plane intersect at a point. There's a plane. The line is going through the front of that plane. Notice you can't see it right here because it's extending out behind the plane, and then here it is finishing its extension out behind. And it intersects at a point. That is the end of our notes for today. We'll talk about them and work some problems using these in class today. See you tomorrow.